Oviraptorosaurs are distinct for their characteristically short, beaked, parrot-like skulls, with or without bony crests atop the head. The group, along with all Maniraptoran dinosaurs, is close to the ancestry of birds. Some researchers have proposed that they may represent primitive flightless birds. Incisivosaurus had a strong bite force, comparable to much larger ornithomimosaurs. Its moderate jaw gape suggests it fed on tougher vegetation than other herbivorous theropods like ornithomimosaurs and therizinosaurs. This dinosaur may have been a generalist or a specialist, using its powerful bite for niche partitioning. Its most unusual feature is its adaptation to an herbivorous or omnivorous diet. The name comes from its prominent, rodent-like front teeth, which show wear patterns typical of plant-eating dinosaurs. Avimimus was another bird like Maniraptoran from the late Cretaceous. It was 1.5 meters long and 1 meter high, and was found in the Nemegt Formation in Mongolia. It had a small skull, but a large brain and large eyes, indicating that it was probably nocturnal in some form. It had very small teeth and a beak, probably indicating that it was an herbivore, omnivore, or even insectivore. It had short arms, with clear attachment points for feathers, however it could not fly. It had very long legs, close in proportion to those birds that spend most of their time running, indicating that this was the lifestyle of Avimimus as well. It is known from many individuals, including adults and subadults with very little variation in size, indicating that their growth was determinate. It was a social animal, given that it was found with many other individuals of its own kind. It lived in the middle of an arid environment with dunes, sand, and interspersed streams. Caudipteryx was one of the first non-avian dinosaurs discovered with well-preserved feathers, confirming that feathers were not unique to birds but evolved in some theropod dinosaurs. Its feathers were likely used for display or insulation rather than flying, suggesting an early evolutionary function for feathers before flight. It had many other avian features, such as a beak-like mouth and short tail. These traits make it a significant transitional form between non-avian theropods and birds, supporting the theory of birds evolving from dinosaurs. It had a short, stiffened tail, much like modern birds, which hints at further adaptations for balance and display in its evolutionary lineage. The presence of unambiguous feathers in an unambiguously non-avian theropod has the rhetorical impact of an atomic bomb, rendering any doubt about the theropod relationships of birds ludicrous. However, not all scientists agreed that Caudipteryx was unambiguously non-avian, and some of them continued to doubt that general consensus. Caudipteryx is thought to have been an omnivore. In at least 2 specimens, gastroliths are preserved. As in some herbivorous dinosaurs and modern birds, these gastroliths remain in the position where the animal's gizzards would have been. Caudipteryx was larger than Caudipteryx. Paul in 2010 estimated the length at 1 meter, the weight at 7 kilograms like Caudipteryx. It had a short snout with a down-curved lower jaw. It had relatively short arms and long legs. It also differed from its relatives by possessing a dagger-shaped pygostyle, the bone at the end of the tail to which feathers anchor in birds, consisting of the 2 most extreme tail vertebrae and several unique features of the back vertebrae. The holotype specimen lacks traces of feathers, but he and colleagues speculated that they were probably present based on its pygostyle, the anchor point of long tail feathers in modern birds. Anzu was a large, bird-like dinosaur characterized by a toothless beak, a prominent crest, long arms with slender claws, powerful legs and a short tail. It measured around over 3 meters long, stood 1.5 meters tall at the hips, and weighed between 200 and 300 kilograms, making it one of the largest Oviraptorosaurs in North America. Several unique traits were identified, including a high crescent-shaped crest, a wide occipital condyle and specific features of the jaw, radius and ankle bones. Anzu likely had an omnivorous or herbivorous diet, with its beak less robust than its Asian oviraptorid cousins, and it probably ate a variety of food, from vegetation to small animals and eggs. Its fossils were found in floodplain mudstone, suggesting a different lifestyle from its Asian counterparts, which lived in arid environments. It was likely a fast-running, ecological generalist, displaying behaviors similar to both modern birds and other dinosaurs. Despite its bird-like features, Anzu was not an avian dinosaur but a result of convergent evolution. Its large, delicate crest was likely used for display, possibly to attract mates, similar to the modern cassowary. Babelang was identified from fossilized dinosaur eggs and an embryo discovered in Hunan province in 1993. The unprepared specimen, known as Baby Louis, was imported to the United States and featured in National Geographic, named after photographer Louis Cihoyos. The fossil remained outside China for over 2 decades before its return allowed proper study. Fossilized eggs are among the largest ever found, measuring up to 45 centimeters and weighing about 5 kilograms each. They were arranged in a ring-shaped nest, likely spanning 2 to 3 meters and containing over 2 dozen eggs. Initially, the baby Louis fossil's size puzzled researchers because the eggs were too large for any known Oviraptorosaur species. Though the embryo was poorly preserved, researchers like Darla Zelenitsky identified the eggs as belonging to an Oviraptorosaur based on the eggshell characteristics. This suggested that baby Louis's parents were enormous, far larger than any previously known Oviraptorosaurs. Dinosaur embryos are rarely preserved, making this discovery particularly remarkable. Ring-shaped nests from smaller Oviraptorosaurs show adults sitting in the center, suggesting that Babelang likely displayed similar brooding behaviors. With a parrot-like skull, feathers, and a 2-legged stance, weighing around 3 tons, was likely the largest dinosaur to brood its eggs. Gigantoraptor is the largest Oviraptorosaur discovered, standing about 5 meters tall and weighed roughly 1.4 tons, dwarfing other members of its family. Despite its enormous size, it likely had feathers. This suggests that feathers evolved not just for flight, but also for insulation, display or other functions in non-flying dinosaurs. The discovery of Gigantoraptor was surprising because Oviraptorosaurs were typically much smaller. Its size challenged scientists' assumptions about the relationship between body size and evolutionary traits in theropods. Like other Oviraptorosaurs, it had a toothless beak. This indicates that it may have had an omnivorous diet, possibly feeding on plants, small animals, or even eggs. It likely had crests or other display structures, which could have been used for courtship or signaling to others, similar to modern-day birds like cassowaries. It may have exhibited a nesting behavior similar to smaller Oviraptorosaurs, potentially brooding its eggs despite its enormous size, providing insight into parental care in large theropods. Its lightweight, hollow bones are more similar to those of birds than other large theropods, hinting at a bird-like metabolism and possibly even behaviors such as fast movement and high energy levels. It had long arms with sharp claws, which may have been used for foraging, digging, or defending itself, adding to its versatility as both a predator and scavenger. Its bird-like characteristics, such as feathers and hollow bones, contribute to understanding the evolutionary link between non-avian dinosaurs and birds, especially how some dinosaurs retained bird-like traits despite their massive size. Caegnathidae was characterized by long arms ending in slender relatively straight claws, and long powerful legs with slender toes. In 2016 Paul estimated its length at 2.5 meters and its weight at 100 kilograms. Caegnathidae was probably an omnivore or herbivore, based on evidence from the beaks of related species like Anzu. In 2005, Phil Center and Michael Parrish published a study on the hand function of Chirostenotes and found that its elongated second finger with its unusually straight claw may have been an adaptation to crevice probing. They suggested that it may have fed on soft-bodied prey that could be impaled by the second claw, such as grubs, as well as unarmored amphibians, reptiles, and mammals. However, if Chirostenotes possessed the large primary feathers on its second finger that have been found in other Oviraptorosaurs such as Caudipteridae, it would not have been able to engage in such behavior. Apatoraptor is a recently named genus of Oviraptorosaur from the Horseshoe Canyon Formation in Alberta. It is known from a fairly well-preserved partial skeleton and skull, and it had quill knobs preserved on its arms. Though phylogenetic bracketing would imply that it had wings already, it's always nice to have confirmation. It probably used its wings for display to mates, as Oviraptorosaurs were incapable of powering flight. It was 2 meters long and probably weighed about 180 kilograms. It is especially important in helping to better understand the evolution of Oviraptorosaurs in North America, which have a relatively sparse record compared to their Asian relatives. Caegnathidae measured about 2.5 meters long and weighed about 90 kilograms. It was a large Oviraptorosaurian, with some specimens suggesting it achieved sizes comparable to its relative Anzu. Like Anzu, it had a toothless lower beak that was shallower in depth than those of Elmasaurians. It also shared with Anzu less gracile proportions than those of Elmasaurians. The status and relationships of Caegnathidae to other Caegnathidae Oviraptorosaurians began to be resolved with the discovery of more complete specimens in 2014 and 2015. The description of Anzu in 2014 represented the first nearly complete Caegnathidae, and helped to clarify the differences between the more fragmentary specimens. Microvenator was an early Oviraptorosaur, closely related to later species like Anzu, and was initially thought to be small due to being known from juvenile remains. While the juvenile measured about 1.2 meters long, adults likely grew to around 3 meters. It had a squat body, a shorter tail without a pygostyle, and long arms with feathered wings, along with a fan of feathers on its tail. Its diet was probably omnivorous, consuming a variety of plants and small animals. Though little is known about its skull, it likely had a large beak. Like other Oviraptorosaurs, Microvenator likely cared for its young, sitting in the center of its nest to warm the eggs. It was a feathered, warm-blooded, and active animal, using its wings and feathers for display and communication. While Oviraptorids were generally 1 to 8 meters in body length, Yulong was described as chicken-sized by its describers. Most of the Yulong individuals had a total body length of 1/4 to half a meter, making them some of the smallest known Oviraptorids. The front upper corner of the fenestra antorbitalis and the rear upper corner of the bony nostril are positioned at about the same height. The rear upper process of the premaxilla touches the upper rim of the fenestra antorbitalis but not the front process of the lacrimal. The nasal bone separates both bones. The parietal approaches the frontal bone in length. At the 4th and 5th neck vertebrae, the rear edge of the vertebral centrum forms a straight line between the postzygapophyses. According to the authors, the hind limb proportions of Oviraptorids do not essentially change during growth, indicating a more sedentary lifestyle and thus probably herbivory. Oviraptor's name means egg thief, based on the initial discovery of its fossils near a nest of eggs thought to belong to another dinosaur. However, it was later found that the eggs were likely its own, meaning Oviraptor was actually protecting the eggs, not stealing them. It had a toothless, parrot-like beak. This beak was likely used to crush or manipulate food, suggesting a varied diet of plants, small animals, or possibly eggs. Its fossils have been found in brooding positions over nests of eggs, much like modern birds. This suggests that they cared for their young, warming the eggs with their bodies, a behavior previously thought to be unique to birds. It had a prominent bony crest on its head, which was likely used for display purposes, possibly to attract mates or signal to others within its species. It had a lightweight, bird-like skeleton, indicating it was probably fast and agile, aiding in catching prey or escaping predators. The pose of the holotype of Oviraptor along with the association of eggs, suggests that it was trapped over the nest during a sandstorm, and burial was relatively rapid given that the body had no opportunity to become fully disarticulated or scavenged by predators. The paleontologist Kenneth Carpenter also agreed in that sandstorms may have been the most likely event that the eggs found in the deposits were buried. Among elements, the skull has become particularly flattened and distorted during the fossilization process. Rhynchinia was a small-sized oviraptorid, estimated at 1.7 meters and a body mass of about 25 kilograms. Several features of its skeleton, especially in the skull, show it to be distinct from Oviraptor. Its skeleton was more lightly built and less robust than that of Oviraptor, and while the crest of Oviraptor is indistinct because of poor fossil preservation, Rhynchinia had a well-preserved, highly developed, cassowary-like casque which incorporated many bones in the skull that are free of the crest in Oviraptor. In 1984, a nearly complete Oviraptorid skeleton was discovered in the Nemegt Formation of the Gobi Desert, leading to the naming of a new species, Oviraptor mongoliensis, by paleontologist Rynchen Barsbold in 1986. Later revisions reclassified the specimen under a new genus, Rhynchinia, recognizing its distinct skeletal features and honoring linguist Byamban Rynchen, Barsbold's father. Psittapodi was a large oviraptorid, measuring 3 meters long and weighing between 75 and 110 kilograms, making it larger than most Oviraptorosaurs genus. It had a long neck, a short tail, and featured a pygostyle, indicating the presence of large wing and tail feathers. A 2022 study revealed that Psittapodi had a powerful bite, scoring between 350 and 500 newtons, likely allowing it to consume tougher vegetation than other herbivorous theropods in its environment. The examinations suggest Oviraptorosaurs may have been powerful biting generalists or specialists that partook of niche partitioning both in body size and jaw function. Of the oviraptorids examined in this study, Psittapodi had one of the most powerful bites, but its biting mechanics were unique among the Oviraptorosaurs investigated. Fossils of Psittapodi are primarily found in the Uka Talgod locality of the Jadokta Formation. This area featured large sand dunes and short-lived water bodies, indicating an arid to semi-arid climate during Psittapodi's time. Although fossilized dinosaur eggs are rare, Psittapodi eggs and Oviraptorid eggs in general are relatively well known. Along with the 2 known nesting specimens, dozens of isolated Oviraptorid nests have been uncovered in the Gobi Desert. Psittapodi eggs are elongatoolithid, which are shaped like elongated ovals and resemble the eggs of ratites in texture and shell structure. Conchoraptor was a fairly more advanced oviraptor from the Nemegt Formation in Mongolia. The found specimen was a juvenile and was found without a crest, indicating that the feature would grow with sexual maturity. It lived in an arid environment with fields of sand dunes and some streams. Internal connections between both ears functioned as resonance chambers and improved hearing. It was a small dinosaur, at 3 meters in length. Unlike many other oviraptorids, Conchoraptor lacked a head crest. Like its relatives, it lacked teeth. Instead of teeth, oviraptorids had powerful beaks, possibly adapted to crushing mollusk shells. The skull of Conchoraptor was heavily pneumatized, with most of the bones hollow. The crest of Corythoraptor is apparently quite similar to the casque of the modern cassowary. The cassowary uses its casque to dissipate heat from the brain cavity, and as a resonator to aid in the detection or gauge the point of origin of low-frequency signals across a greater distance. In Corythoraptor, the latter may have been used to hear predators or prey items, or possibly to pick up low-frequency mating calls as modern cassowaries do. However, it is unclear if it was capable of producing low frequencies since these are produced in the throat. Like other oviraptorids, the bones of Caegnathidae were heavily pneumatized with many air pockets. Microanalysis of the bones indicates seasonal growth spurts, and the type specimen probably died at the age of 6 or 7, meaning growth continued into at least the 8th year of development. The type specimen reached 1.6 meters in length. Oviraptorids may have predominantly inhabited arid environments and ate drought-resistant plants, nuts and seeds. However, Caegnathidae coexisted with 6 other oviraptorid genera, and they may have all eaten different foods. Heywania was a medium-sized oviraptor and was the first one found in China. It was about 1.5 meters long and less than 1 meter high, and is known from a partial skull and most of the skeleton. It was toothless, making its diet, as well as the diets of other oviraptorins, uncertain. It was found with a lot of eggs, some of them theropod-like, and thus probably the eggs of Heywania. Preservation of the pigments biliverdin and protoporphyrin in eggshells belonging to Heywania indicate that they were blue-green in color. This coloration allowed for both camouflage and sexual signaling, also seen in American robins and ratites. The arrangement of the eggshell suggests a partially open nest arrangement for Heywania, and also indicates that it engaged in increased parental care.